We are Collins Aerospace. I'm Alec Terwilliger.
I'm Jeremy Jager.
I'm Ian Wallace.
And I'm Felix too.
So just a quick overview of what we'll be talking today. First, we'll talk about Collins Aerospace as a company and who they are. And then we'll talk about what they wanted from us and then the solution that we will provide for them. And then we'll show how our schedule progressed throughout the semester on our project. And we'll give a quick demonstration on the progress we've made since our midterm. And then we'll also talk about issues and risks we had and a quick follow-up summary with the next steps to take. So Collins Aerospace as a company, they make aircraft components, and that includes anything from software to hardware components. Our sponsors are Mike and Steve. They've been super excellent. They've given us a lot of valuable feedback and have been able to answer any of the questions that we've had about our project. So what Collins needed from us was a way to reliably transfer files or software components to an aircraft, and they wanted us to provide certain metrics on how we accomplished that. And this has changed a little bit since our midterm presentation. Basically, they wanted to know what types of files that we can crate and how our crates would fail validation if they were to fail. And then they also wanted API documentation from us, and as well as our project growth path documentation. So our solution to this was split up basically into two parts. There's crating and uncrating. Crating is basically securely encapsulating certain files and software components inside a crate. And the way that we accomplished this was digitally signing the crate as well as the crate contents. So then when we uncrate the files, we need to verify the signatures to ensure that nobody got into that crate and maybe deleted files or modified files or even added files to the crate. And then we will also unpack those files for distribution. And it's important to note that we don't actually handle the transfer of files. Collins already has a secure way of implementing that themselves. So just a quick burn down chart for our project. We started off relatively slow in our first sprint. We had a lot of research and initial setup to do, but the bulk of our project we were able to get done in our second and third sprints, where we handled crating and uncrating. And then sprint 4 was a lot of just documentation and follow-up on that. So now I'll turn it over to Ian.
So, as a quick review of where we were at the midterm, we had most of the crating process complete, but to get to that point, we had to learn how to use Docker and integrate it into our current workflow. We had to set up an Amazon Web Service to host an OS running Ubuntu that held that Docker container. We could pass in files using kind of our dummy GUI, and we could build out a crate manifest with the files that we gave our API. We could zip those contents and return the zip file to download for the user. So this is the progress we've made in sprints 3 and 4, so post-midterm. We were able to finish out the crating process by adding in the ability to have a digital signature using a PKI certificate. And then we worked through the uncrating process, which a lot of that is validation. So validating crate structure, making sure that everything is laid out in the ARINC 827 spec doc, that we could hash all the contents in the crate, and that we could properly build out the crate manifest. So then, continuing for documentation and testing, a lot of sprint 4, we worked to create modified crates. So creating a crate that should pass validation, and then modifying the contents of that crate, which we'll go over in our demo. So deleting files, modifying files, and making sure those modified crates failed validation. We also documented that test process and how the API was supposed to work. So kind of a review of what we had to learn for technologies and research. We had to go over Docker, Amazon Web Service. We also had to use and implement Spark and Jaxby into our project to handle HTTP requests and other web services. This is kind of a brief component design. So you can see we have the Amazon Web Service hosting Docker, which contains both the GUI and our web server that hosts the crate builder and crate validator. And this is an overview of what the crate manifest looks like. So we've got a crate that contains two main portions, the signature that's formed using the PKI certificate, as well as the crate data, which contains a host of information on the rest of the contents of the crate, such as the item list, other files, and then the assembly information. Now we'll go over a brief demonstration on how this process works.
And so now that we've talked about what our project and solution is, we can go through our actual demo of it. And here we just have our web page already filled out with some of the information to save a bit of time. Just a reminder that for our project, the important functionality is the functionality of the API that we're providing and not the GUI, which is why we just have a basic HTML web page here. At the top, we have selected just a single software component that we're going to be adding to the crate, as well as some information about that software component. And then here we have some newer information such as a manufacturer's code and identifier string, and these are going to be used for naming the crate. We also have some more general crate info such as the crate ID or the description of what the crate is as a whole. And we have some newer optional fields as well, such as the tracking number, which could be useful for the recipient. Here we have selected a single text file. This is just a standalone file that will also be added to our crate. And we also have selected our PKI certificate. This is a .p12 file, and it contains the public and private key that are going to be used to sign our crate. This file is password protected, so we also have to pass in the password for that. And once we have everything filled out for our form, we can go ahead and click upload and send this to the server. And our server will respond with a zip file. This is the crate that we can then download. We can open this up then and take a look at the contents. So, zoom in a bit.
Oh yeah.
So at the top we have the documents folder. This just contains the standalone documents. In our case, we had that single text document. In our parts folder, we had all the software components that we had passed in. Again, we just had that one single software component. And then finally, we have the crate.xml, which is our manifest file. And so we can take a look at the contents of that. This first part at the top is what we had for our midterm presentation, which is the crate data. It contains all the information about the crate items that we passed in, the various information in the fields that we had included in our form. And the second part, the signature, is everything related to the digital signature. And so this is what we had worked on past the midterm. It begins with the various algorithms that were used for the signing process, the hash values that we had calculated. Here, this giant blob of text is the public key that's associated with our certificate we used. This is what's going to be used to validate the crate signature. And finally, we also have a list of every single file in the crate and a hash value calculated for every single one, so we can verify the integrity of all those. And so now what we can do is we can go back into our application and pass this to our uncrating process. So here we had just created this crate using our application, so we would expect that our crate should be valid when we check the valid. And so our server responds that the crate is indeed valid, and it informs us that the crate was created with method 1 and was successfully validated. So now what we're going to do is we're going to go through some examples where we modify these crates and show that our application can correctly identify when these have been tampered with. Because properly validating a valid crate is only one portion of our project. We have to also be able to, really the important thing is catch the ones that have been modified. So we're just going to make a few copies of this crate that we had just made. And we can open up the first of these copies. And what we're going to do for our first example is we're just going to delete one of the files out of it. So we could go into our parts folder, open up that software part that we had, and just delete one of these files out of it. So at this point, our crate has been tampered with. We know that this crate should no longer be considered valid, and we need to make sure that our application is able to correctly identify this when we pass it for validation. So we can just select the file. We can select this second crate that we just modified, and when we pass it off to the server, we should see that this crate is no longer considered valid. And our server will inform us that the provided crate does not contain all of the files that are expected in the manifest digest list. So it knows that there's one of these files that's missing. For our second example, we are going to actually modify one of the files rather than removing it. And so for this one, we are going to modify our text document. So in our current crate, the text document, there we go, it's perfectly valid, nothing wrong with this text document. But what if a malicious attacker were to replace this with their own modified or altered version of this? So here we have this modified text document, and we can just copy and replace it into our crate. Now, once again, at this point, our crate should no longer be considered valid, as the contents of it have been altered. And so we could go back to our web application and select this new crate. And once again, when we pass it to the server, we should see that the crate is no longer valid because the calculated digest for that text file is not the same as the one that's listed in our manifest. So we know that it has been modified. And for our third and final example, we are going to actually modify the manifest file itself. And so we can't actually modify the file directly within the zip file, so we're just going to copy it out, modify it, and paste it back in. So here we can open up our manifest file, and one possible change that an attacker might make is to change the location of our software part. And because right now it's pointing to one of the files that's in our crate, but because this is just a URL, the attacker could potentially just replace this with some malicious website. And so in our example, we'll just replace it with www.hackedwebsite.com. And then once we save this, we can copy it back into our crate and replace the previous manifest file. And at this point, once again, the crate is no longer valid. We need to be able to identify that this manifest has been altered. So if we go ahead and select this third crate, our server will respond that it is again not valid because the provided crate has an invalid digest value for the crate data and the crate item list. So for all these cases, we were able to correctly identify that the crate has been tampered with. And now I will pass it off to Eli to talk about some of the issues and risks that we faced.
Thank you, Jeremy. Just a quick overview. I'm going to be talking about some issues and risks we had during the entire project, our post-mortem, and the next steps that the project's going to take after we hand it off. So some of the issues and risks we had is, one issue is in the very beginning we were given a PowerPoint. You all saw it during the phase where we were picking the projects, and buried in the PowerPoint was a bunch of information about the crate itself. And it so happened to be that some of that information didn't cohesive with our 827 spec that we're giving at the beginning to say how we made the crate. That was a simple fix. We just went to Collins, we asked them about it, they brought in an expert, he told us, hey, don't worry about it, just go off the 827 spec. Another issue we had is our testing was pushed back, mostly to this sprint, and we needed to focus on implementing the functionalities of our document, or our project. So, excuse me, the testing was pushed back, and so it might not be as thorough as we would hope, but we are working hard to make sure that we get it as thorough as possible. The biggest risk of this entire project, I'd say, would be that we would validate a crate that actually isn't valid. I mean, the whole point of our project is to make a crate and make sure that it's valid, because that's what Collins wants from us. And to make sure that we don't do this, like I said before, we're doing all this testing and to make sure that this problem doesn't. Now we'll go over a little post-mortem of what went well and what didn't went well. What went well is our mentors were awesome. Thank you very much. We had a couple of changing requirements. This is our first major project we've done with a big spec doc, so of course our requirements weren't perfect from the beginning, and we had to change some as time went on. They were very fine with that. They helped us out. They made sure everything was going well. And thank you again. Again, with the mentors, whatever we needed, we got. The certificate, like I said, the help from questions, anything we came forward to them, they stepped up to the plate and helped us out, and thank you again. A couple of things that went bad is the weather. It knocked a couple of our meetings out, and nothing too much we can do about that, unfortunately. And then another problem, or another thing that didn't go as well is for our sprints, we kind of would always start off a little slow and then get into crunch time as time would go on, which, sorry, but we were college students. But that's. And then next steps. Of course, we're going to hand everything off to Collins, like the API, our testing results, and project growth path of what we did, why we did it, and all that information. We're going to have a final review with our mentors and then get feedback from Collins on how well or how not well our project went. And then after we give it off to Collins, they're going to take it and implement some of the stretch goals that we didn't get to, like giving an output directory where it would, after we put the crate in to validate it, it would put the uncrated version of the crate into there. And another one would be the status bar, which I'm sure you saw up there. That's not functional, but that's because there's a stretch goal. And then after we give it off to Collins, they're actually going to rewrite our code, because of course we're college students, we're not exactly into the real world yet. And they're actually not going to be using Java, which we used for this project. They're going to write it in whatever language they see fit. And then to better fit the code base. And then what's kind of cool is Collins have already started bids on this project, so it's getting traction, and they're going to use our project as a base for theirs. So, quick conclusion before the questions. Today we are the Collins Aerospace group. We talked about the company, we talked about the problem and our solution that they came to us with. We gave a little bit of our schedule, gave an awesome demo, talked about our issues and risks, gave a little post-mortem, and talked about the next steps. And then, any questions?
I really like it. This was really nice. We had one question at the very beginning. The problem was what kind of files can you deal with and what kind of files are failing, and I didn't really see that being answered.
Do you want to take that or should I? So I was thinking the one issue that we did have with a certain type of file was just, I mean, it wasn't necessarily the file extension, but certain files with spaces in them, like in the names of the file, didn't go too well, which maybe just on our end, like our input validation, but it was just something that we had found. But most, just any generic file with a file extension would work, basically.
And it also depends on when you're filling out the form, there's different information like the different crate item types or the different software component types. Some of them might be expecting a certain header file, and if that's not included, it could cause issues when it's trying to find that and it can't find it.
You're showing all the different ways it could be invalidated. When there's multiple things wrong, will that message returned from the server contain everything that's wrong, or just one
Currently, our message would just be the first error that we had encountered with it. Any other questions?
So now that you guys have been through the project, and we talked, a little bit at the beginning of how we would try to run it, and then of course we've gone through it and things change, and that's part of, kind of working in agile methodology. What would you guys do different if you were able to start this project again and kind of redo it? And how would you implement anything, any changes that you want?
I would start sooner, like just try to begin the actual project, and like a lot of our initial hours that we put towards the project were for research and development and just setting up, and I feel like that pushed back our actual development of the project further than we probably could have started it, and that ended up pushing our testing back, which was very important. So yeah, just getting through the research and setup processes sooner would be very helpful.
Yeah, some of those things you're obviously going to have to do the research and the setup eventually, and it's more just accounting for it ahead of time.
Thank you.